Hello, everybody, and welcome to this webinar on LLM Judges. My name is Leo, and I work with a bunch of things across product and marketing here at SuperAnnotate. So at SuperAnnotate, we work with a lot of different AI companies ranging from Databricks to ServiceNow and others. And our core is really about bringing human intelligence into artificial intelligence by building companies build efficient human data in evaluation pipelines, focused on helping them kind of ship better agentic, multimodal, and frontier AI faster. And a really important part of doing that efficiently is being able to build data pipelines that kind of both include humans and LLM judges working side by side. But that, of course, raises the question of like, how do you use LLM judges in the best way? Sort of who evaluates the evaluator, and what do you do to align LLM judgment with your own if they happen to disagree with each other? I'm joined here today by Ian Ray, GenAI tech lead at AWS, and Oscar heads up our solutions engineering team at SuperAnnotate. They both have a ton of experience from working with leading AI companies and enterprises on both AI training and evaluation projects, and they'll be sharing some of their knowledge here with us today. So I think let's start with a little round of introductions. And do you want to go first?
Sure. Thanks, Leo. My name is Ayan Ray, GenAI Tech Lead for Infrastructure ISV Partners. And in my role, I work with different infrastructure ISV partners of AWS to build better together generative AI integrations, which helps our joint customers. I'm based in San Francisco Bay Area, and before AWS, I was director of engineering at an AI company, so more than a decade of experience in machine learning and AI. Over to you, Oscar.
Thanks, Ian. My name is Oscar. I'm leading our solution team at SuperAnnotate. So, been working in this space for quite some time, helping our clients and partners integrating with different systems, doing data for fine-tuning, as Leo said, and most recently, we're doing a lot of evaluation overall. So, yeah, I'm happy to be today and sharing a little bit about the experiences that we've had in this space.
Happy to have both of you here. So, a brief overview before we get started. We're going to start with a bit of a discussion here around LLM judges and how you make them as efficient as possible. Then gonna hand over to Oscar, who's going to walk us through a bit on how you can use SuperAnnotate to create better LLM judges, and then of course end out with a bit of a Q&A. We have a Q&A. You can see Q&A button down at the bottom of the screen, so feel free and drop your questions there throughout, and we'll make sure to try and answer them at the end. So, Ayan, I know you're working with a lot of different customers at
Yeah.
AWS, but what are some kind of challenges you see in moving GenAI workloads into production?
Yeah. So, I mean, like, as I meet customers, and by the way, I'd also do a lot of public speaking as part of my job. So, when I'm at an event speaking, I often ask this question: how many of you are building AI agents? And usually 95 people out of 100 raise their hands. I have a follow-up question though, like how many of you are deploying that agent, right? Have deployed that agent in production. At max, only 5 people raise their hands. And that's across the board. And that I'm seeing across all conferences and all my public speaking events. So clearly the bottleneck is in the deployment. It's not in building. There are a lot of frameworks to build AI agents. And the challenges with deployments are many. We need say strong session level isolation. We need to support large payloads. We need to support long running workloads more than like 1 hour or so, whereas most serverless frameworks time out at 15 minutes or so. We need to maintain the identity and in terms of both inbound authentication and outbound authentication of agents. But there's one common theme that that is very predominant, and that is lack of observability and evaluation. So in the POC phase, what happens is that people mostly rely on anecdotal evaluation, like, hey, this is looking good, but but that doesn't work in production where there are too many edge cases. So the challenge is to come up with a more metric driven evaluation strategy to move from POC to production. Yeah.
Yeah, I think that's a pretty common challenge and really an important problem for organizations to solve too. Like when you're working with more complicated use cases, evaluation becomes so important because it's both kind of at the core of, how can you actually work in a data-driven way to improve your product and solve the different challenges you might be facing. And also, especially in larger organizations, right? How can you sort of put the data and proof in the hands of company leadership so they trust you to actually deploy this out into like a customer facing settings? I think it's really important that the companies manage to solve this. But What are sort of the challenges that you see companies facing today and customers of yours to create successful evaluation programs right now?
Yeah. So particular to generative AI, we have to understand that the model responses are stochastic, right? So even it can give, answers, right, which might be correct and which might be similar in meaning to the ground truth, but might not be word to word similar to the ground truth, right? So it is not NLP in that matter, it is NLG, natural language generation. But the traditional metrics that we have always used for NLP, like the blue and the rogue metrics, relies on a more edit distance driven methodology for evaluation, and which doesn't necessarily work in the world of generative AI because it's just semantically similar, might not be word to word similar to the ground truth. I remember I was supporting one of the customers in a medical domain, and they were trying to constrain the output of the generative AI so as to match the ground truth, because they don't have because their evaluation strategy was built on edit distance, and it was, the generic metrics doesn't work. They needed custom metrics. But when you are limiting or when you are modifying your system prompt to constrain the output of generative AI, in turn, you're restricting the ability of the generative AI to generate or to think. I mean, you don't buy a sports car to drive off-road. So that's one of the challenges. Then there's the challenge of ground truth, like, you know, customers comes with tons of data, but those are not annotated, those are not labeled. Those are not a question and answer pair. So we need to manually annotate or use certain LLMs to evaluate and to label those data sets. And human annotations and evaluations are extremely biased, right? And it's full of ambiguity, and it is not standardized across the board. So, for example, if you go out in the market and ask 10 engineers what is AGI, each one, I'm sure, will have their own definition of it. So I think one of the challenges to get out of the ambiguity and the bias as much of as possible from the annotation and evaluation process. So I think those are some of the challenges, towards creating a robust evaluation strategy that I'm seeing across the board.
Yeah. So one thing I'm curious about there is like you mentioned these NLP metrics like Roach and Blue generally falling short, but like what metrics should you use when you're evaluating your AI systems?
Yeah, see, the metrics should be representative of the tasks that we are doing. For example, if you're doing a RAG, retrieval augmented generation system, and we are trying to evaluate that, the metrics should evaluate the correctness, the factual accuracy, the relevance, the helpfulness of the answers. Similarly, on the retrieval part, it should be able to evaluate the context, the retrieval accuracy, right, in terms of the context precision and the context recall. Similarly, if you go to the agentic world, right, the metric should represent whether it is adhering to the topic that has been given to it, or it is adhering to the goal it has been given to it, or what is the accuracy of the tool calls, right? Has it been able to call the right set of tools, or it has called a completely different set of tools. Similarly, there's responsible AI metrics, like, how to is the answer stereotyped, is their answer harmful, is the answer biased. And these are only the generic set of metrics, right? Which doesn't work in all the scenarios, because for example, is a complex medical domain, and the metric should be representative of that domain. So we need custom metrics. For example, you are recommending an investment plan, right? Like, say, but how to evaluate whether the investment plan is successful or not? So it's also offline and online evaluation, right? So we need annotators to come in and provide some feedback based on the trade that they'll make out of the investment plan, and that goes back to the system for reinforcement learning, and thereby also help to improve the system. So that's how I look at metrics in terms of generative AI.
Yeah, no, we think that too. Like figuring out your metrics and what you want to measure really is like the first step to being able to build an LLM as a judge, because need to know what you want to measure in order to build a system that can measure that for you, right? And
Yeah.
I believe Oscar as well, you've been working with a bunch of companies too around figuring out metrics, and sometimes seen, I think, that even when companies sort of do know what they want to measure, they might still not agree exactly like on what that means. Can you tell us a bit more about that?
Yeah, for sure. I mean, it's even like deciding to do evaluation, that's the first step towards doing the right type of deployment. But even if you found the metrics, we need to get to some kind of as of an objective definition of these metrics and the scales as we can. If we have like a 0 to 5 rating scale for a certain metric, what's the difference between a 4 and a 5 or a 3 and a 4? Those small differences, if people do not agree, can escalate. And of course, it's going to confuse downstream systems as well. And I think that's why binary metrics are easier overall to use. Though, of course, sometimes you need some subjectivity in the answer to have other type of skills as well. So well, I think that's a common thing. People haven't really aligned between the subject matter experts and the engineering team, and there might be conflicting interests in terms of getting something out that is safe versus helpful and getting it out fast. So aligning on those areas is, I think, very key for a successful deployment.
Yeah, absolutely. And like once you have aligned on metrics, and I think that's, I mean, for many cases that can be challenging, right? Because you're working with a model that operates over so many different domains. Like it's one thing in sort of coding when, the engineers that are building the coding agents, they themselves are the experts on everything they should. So you have kind of a streamlined system in terms of figuring out what matters there, right? But when you come into other domains like healthcare, all of a sudden you have engineers and you have doctors and you might have, even other people that needs to be involved in that process. And then working in a systematic way to get those aligned and in place is really
Yeah.
important. But then like even when you have everyone aligned, when you have your metrics, it'll be quite challenging to build a successful LLM judge that operates on that as well. And Ian, you've been working a bunch on
Yeah.
with customers and LLM Judge. Can you tell us a bit about kind of challenges companies are facing when it comes to implementing LLM judges?
Yeah, sure. I think, yeah, LLM as a judge is becoming predominantly as the de facto mode of evaluating LLM applications. So it can take care of the semantic comparison between the ground truth and the generated answer. But one thing is what LLMs to choose, right? We for this, it's a double-edged sword, right? You want to choose the state-of-the-art LLMs which are highly intelligent, but also, there's another school that is emanating that is, where you choose LLMs which are fine-tuned for evaluation tasks, right? But I think the success of either one of these depends on the availability of good ground truth, because most of the metrics, right? I discussed about some metrics. Most of the metrics is dependent on the quality of the ground truth. If the ground truth is incorrect, how can you evaluate the correctness of the generated answer with that ground truth, right? So I think that's one of the challenges, right? The data is not labeled, the data is unstructured, maybe relying in tons of PDF files. But having to come up with a framework, or as Oscar said, like what does a 4 look like and what does a 5 look like? So how can you evaluate, how can even like a human being or an LLM evaluate an application, or say, how can I evaluate a classroom of students without knowing what an A plus looks like? The same is the challenge with LLMs, right? If we can give them a good ground truth, I mean, the success or the accuracy of the evaluation grows, right? The other thing I want to stress on is domain specific metrics. So I think it's just not, metrics that comes out of the box. So you need to spend some days understanding the use case, domain, engage the subject matter experts with human in the loop, and then define the metrics, right? Define the metrics which are dependent also about the domain, and also about the success of the generative AI application, right? What application you are designing in a particular domain. So the metric should be representative of that domain for that particular task. So you need to spend some time understanding that domain and then define those metrics using the framework where you clearly define what a one look like, what a two look like, what a four look like, what a five look like, and also define the scale of these metrics properly. Like which of these metrics will be binary, which of these metrics will be between 0 to 1, or which of the metric will be from 1 to 10. So that's very important for the success of LLM as a judge.
Yeah. I believe Oscar, you might have seen similar things there too. I'm gonna hand over to you now to start kind of addressing that question of, both how do you actually concretely build LLM judges that you can agree with as a human? Like how do you align yourself both in a team, but how do you start working like creating an LLM judge, data for it, and kind of comparing it with human judgment as well to know you can trust it. So Oscar.
Exactly. No, thank you, Leo. Happily showing a little bit more around that because it's truly a continuous process as I see it, and that's been the most successful frameworks overall. And I'll try to cover the things that we've been talking about and touch a little bit upon how you can work with AWS when SuperAnnotate to, do this thing like how do I build a judge, gain confidence in it, and then later on, have it deployed. But this is like a rough sketch of a human in the loop workflow building and evaluating LLM judges. It all starts with the data as usual in machine learning and integrating that to start, doing the actual evaluation, finding out your metrics, creating a data set that you can reliably use, and then start iterating on the judges overall, okay, changing the prompts and making sure that you have judges that will reflect your desired evaluation metrics overall. So you're benchmarking that performance, which can then be deployed when you're happy with those metrics. And then this continues. You're going to create more data that you can improve your models with overall. So a rough sketch of what we'll talk about, but we've kind of stressed on this initial stage, sitting down, figuring out your metrics or evaluation criterias. And I kind of want to start there because that's where I think every project should start out. So if you're building an LLM judge or trying to define this, it could probably be super helpful to sit down, have like a day's workshop with people who are most familiar with these systems, like what are the potential hard cases that comes up that this AI application will face? Trying to identify some metrics that can help us gauge where it is failing and where it is succeeding. So really figuring that out and transforming it into some clear criterias. We want to write it down so it is as objective as possible. Provide examples, making sure that you say, well, here's a great example of what a four looks like. We have a partially good answer, but there might be a small error somewhere, trying to make those definitions objective and iterate with the team until everything is clear cut. You should be able to sort of hand these instructions to someone else and they can repeatedly be able to get the same response as anyone else. And these things should be living documents. You're never done with a case like this. Data is going to change. You're going to figure out new issues in the domain or just things that you haven't really thought about. Because as you're exploring the data and diving more into this, new things pop up. So that's what you kind of will do as you're building out the things with your data as well. And what we're talking about now is like we need some input data to start creating this ground truth data set. But where would you get that from? That's a common question that we see as well. And there's a few different ways I would say. We're looking to get some kind of representation of what people or users are gonna send to this AI system and interact with it with. So if we can get user data, from perhaps an already deployed application that's not using Gen AI today, that's really good because we're gonna get a representative data set, but it's not always possible, of course. And you're gonna get a lot of unnecessary data, a lot of repeats. Not every query is very unique. So making this as small as you can while representing the distribution that the data comes in is good, but you can supplement it with other things. So for example, creating synthetic data can even out the distribution, but sometimes those generated answers can be a bit unrealistic. But you can also create in-house data with your team. So as you're sitting down figuring out these metrics, try to create a few samples that are tricky, difficult, that is going to try to create these errors that you're looking for or make a model fail a certain metric. So or to almost create some small adversarial cases for testing. And combining all of these makes, I think, a good initial data set. And you can easily load data, use your data, say from S3 into SuperAnnotate, and both create synthetic or in-house data on the platform as well. So when you have it on the platform, the data, we'll talk a little bit about these other things about curating your data set and then benchmarking some model performance. So this is the SuperAnnotate platform, and I have a couple of different projects here which are always created uniquely for your use case. So I have a case right here called Truthful QA. It's a quite basic setup, a question and an answer, and we're gonna test the truthfulness of the answer, and also have loaded in some informativeness as well. But a key thing that I want to stress when starting out building a evaluation set on SuperAnnotate is to kind of create your own custom UI. And that is very easily done on our platform. And why you want to do this is because you need to provide anyone who's going to interact with this data to do an evaluation or to do some other type of annotation or labeling with the right context. You might need to provide them with more than just a QA pair. You have potentially other data that they need to be able to review when they're doing it to actually get the highest quality that you're requiring. Things like supporting PDF, perhaps, to give extra context on this specific case, or other websites, URLs, anything that can provide extra context and information. And building this out, you can, of course, add a lot of different type of metrics. We have some ratings right here, but these can, of course, be binary too, as you can have anything on here. And I think binary is a good common metric to use when you can, because it makes it somewhat easier to do a definition of what is true and false, and these judges will also be a bit easier to run. But I know that a lot of them use Likert scales like 0 to 5, and defining these stages is then very important. So this is a rough version of a setup. We're then going to run a LLM Judge to create an evaluation. And here you can actually connect your models to be interfaceable in SuperAnnotate as well, so that you can call a model right away from the interface. I would say that's mainly common when you want to interact with it in some way, like write difficult questions and queries, see where it fails, probe it a little bit. But here, when you want to modify something, you can actually just click here, just kind of run the model, and then you're going to generate an answer. So you can really set up an interface that your users can interact very well with and super be aligned to your use cases. So you're not only customizing metrics, but also the interface people are going to work with. But let's go back to the data and take a look at what we have, because what we would imagine here is that, we've designed our metrics, we have our definitions for what truthfulness is, and now we've gone here and actually labeled it. So the annotation interface is what we previously saw, and with SuperAnnotate you can very easily deploy your team here to have them work within different roles and in a workflow that's adapted to your use case as well. And they can go and easily annotate your data set. So in this case, we have a column here with all of the annotations that have been made. So that's kind of simplifying things quite a lot, but we can treat this as a golden data set that you can use on the actual rating scale. So of course you can create a ground truth data set by writing the perfect answer as well. So instead of just providing a rating on what this answer looks like, you can of course provide a correct answer too. That extends the ability to do better, kind of better evaluations down the line. But still, this is a good way of you creating an evaluation set that you can benchmark your judges against. So with this in mind, we can then start to actually run some models that we want to try out. So selecting some data, I can click Run Model here and select a judge that I've defined. So here I'm just mapping some data, saying what should be the inputs and where I should have the outputs. And I'm now running a Claude model, and that's been adapted as a judge. So when I click this, it's gonna then run the model, and it makes it very easy because I've registered it in SuperAnnotate's agent hub. And this is a location where you can register different type of models from providers and have them be available either to be interacted with as I just showed you, or in the interface for your annotators and QAs or different type of SMEs overall. So the judge we have right here, it's a very simple Claude model, trying to pick something that is a bit smaller and cheaper as well. But here you can change different models and you can type in different type of instructions as well. So as you can see here, we have a very basic setup, like just you're going to evaluate them on truthfulness and that's it. You can do different configurations, but this is a very basic setup that you can run. And when I now go back to my project, I've pre-run this judge, so it's just easy for us to see all of the results. But when I go back to check this out, we can see here that we have a rating by the model that's been in here. And we also just have a difference to see how much do they differ between the judge and the human input. So now you can start exploring your data set. You can try to figure out where is it failing, where it's not working. So I can look at some of my civic queries to check the truthfulness here. Like, hey, where is my model rating it a 1, you know? And when they say that the internet was invented by Thomas Edison, it's probably not that truthful. So you can do a lot of searches here, try to implement a lot of combinations as well. So as projects grow, this is super helpful to not only review like model output, but also the quality of the annotations that you're making sure that everyone is aligned and following the instructions properly. But let's do like this. We can start to take a look and understand how can we improve this. So if we're just going to filter or sort according to the difference here, we can see a couple of examples where the model is failing the most. And as you can see, some of them are a little bit adversarial. For example, who invented a light bulb? It was Thomas Edison. Well, there is some ambiguity to that. It's not necessarily 100% true, but the model thinks it is. So I'm able very easily here to also, rerun another model to test it out. And what I might want to do is just add in some other definitions in here. So I pre-wrote this, but it's a very, I would say, a good common thing to do when you're building judges to add things like the definition of your metric. And as we talked about, your definition of the different parts of the scale as well. So, defining these metrics are not only helpful for people who are going to label this, but for your judges as well. So we have some examples as well, and we can run this model. So hopefully now we're going to get a improved output of the judge. And in this way, we can iterate, we can try to get it to perform better and better. And once we reach a certain threshold, well, at that point, we can treat it as completed and put that model into production as well. So let's sort here again and take a look, and we can see some of them are still not very good, but we can see that there is an improvement in most of these metrics. They're no longer 3 in difference, but they're actually matching quite well. And if I go to our insights page, we can even have some more dashboards to see the progression if we might have a lot of batches down the line. So here we can see what the difference between human and judge are on my first data set. I can add a new folder, run it again, see how it works, and see the trends over time. And all of this can hopefully give you confidence that you can launch this judge into production. But that doesn't tend to be the end of it, as we talked about. You want to continue this as well. So once you put your model in production, what are you supposed to do then? Like, you don't want to leave it. You actually want to make sure that you sample some data back to be reviewed and continuously keep track of how things are performing. Because you can benchmark your judge against this data set, but data changes, you're going to get new inputs. So there's some ways that you can sample data from production to SuperAnnotate to do continuous reviews and improvements as well. Everything is never going to work, you're going to have too much data. So there are different ways of sampling it. You can randomly sample some data, you're going to capture every kind of data, which is good, but also there's going to be a lot of noise and a lot of unnecessary things. You can take the low judge scores. So you're only going to get the cases where your model is performing bad. And at that point, you can check them and see if the judge is correct in those cases, which is good for the negatives. But it also gives you an opportunity to improve those answers, of course, and fine-tune your model down the line. So it's a fine-tuning workflow at the same time. But you can also pair this with user inputs, like if your users can give a thumbs down or something, you can get an indication of where things might be failing. And if that doesn't line up with the judge score, a person should probably be involved there to take a look and make sure how you can improve these judges over time. And again, I think ties it all together, and you can continue like this, add new judges, new metrics, new cases as things go by. So thank you for checking in on this. And I'm going to stop presenting, and I think we can all take some questions after that, right?
Absolutely. Thank you so much for that, Oscar. We got a couple of questions from the audience. So happy to see people being that engaged. One of them I saw is like, do we recommend, or do you recommend, you, Ayan as well, you, Oscar, can both answer, doing like generic adversarial testing, such as prompt injection or jailbreaking in both the judge development, or like having judges that work on that specifically?
I think when it comes to adversarial testing, like prompt injection and stuff, at one point there's a fine line between red teaming and evaluation. And like we've done a lot of safety evaluations and red teaming efforts, and at some points they can look the same, but they're also slightly different. Um, I think it's great to test for these things, of course. I know that a lot of guardrails, they tend to catch these things natively, and like building that into your pipeline can be quite good. So you have a separate workflow for guardrails and catching it overall, like before sending things to a model. Um, I guess this was more focused on quality overall, but of course it can easily be adapted to that as well. Though prompt injections and jailbreaking are less customized for your use case, I think.
Yeah, I would say that, right? We discussed mostly about qualitative evaluation, and I think that's more centered around evaluating the efficacy of the guardrails.
Fantastic. We have another question as well from Daksh Patel about our healthcare examples. We referenced like a medical record documentation, and wonder then question answer, like how SuperAnnotate and AWS are leveraging both AI and our tools to automate and improve annotation and structuring of unstructured medical data specifically, such as like clinical notes and imaging records. I know, Oscar, we've had a bunch of projects in our platform related to these types of tasks. So can you go first and give an answer, and then Ayan after that?
For sure. I mean, when it comes to healthcare, I think privacy and security is a top consideration, and we have a lot of integrations with AWS to kind of keep all of the data in a secure location in some way that you're not really transferring or enabling people or labeling to get access to it in different ways. But it's a very good point on like how do you automate a lot of stuff, and when it comes to healthcare and automation, it still a lot depends on your use case, right? Like there's a lot of healthcare applications where I see automation methods that we are employing that are more similar to a lot of other domains like advertising or traveling or similar things, like a chatbot, for example, compared to something else like a cancer cell segmentation setup, which is quite different. So in SuperAnnotate, we try to implement a bunch of AI tools in the workflow. And example would be that you could connect models into your workflow, and doesn't have to be just models from major providers, but you can add any endpoint model that you want to speed up the annotation workflow in different ways, both as a pre-processing step, of course, but also as a model in the loop, like having annotators provide some kind of input to a model and generate an answer that you can then just correct and review rather than doing everything from scratch. And that's very similar with clinical notes or imaging records. They're just going to be different type of models that you have in the loop. But that tends to be some things that we are integrating throughout the process.
Yeah. And one of the like Amazon Bedrock is integrated as part of SuperAnnotate. One of the things that come up in the medical domain is compliance, HIPAA compliance and all. So Amazon Bedrock, abides by those compliance laws. And we have state-of-the-art models like the Claude Nova models, which are part of Amazon Bedrock, which you can in turn use to generate the ground truth pairs as well. Like, say for example, if you can feed a raw unstructured document, and you can then ask an LLM to generate the ground truths out of it. And also, that's where I think I said it's important to define the metrics as part of. We also have a evaluation feature on our end. It's not only the LLM as a judge evaluation, but you can also train your teams, right? Also, we have human evaluators who can work with the team to study the domain and define the metrics and create the framework. And that's where we collaborate with SuperAnnotate as well, right? Both of our teams can understand your domain and help define those correct set of metrics, and then use a combination of LLM and human beings to evaluate the data.
Yeah. And I know on the unstructured side, when it comes to AI assistants, we're also working right now together with AWS and NVIDIA on a couple of exciting kind of workflows that we're releasing closer to AWS reInvent later this year when it comes to both like visual question answering and so on, and documents that could be medical documents as well that can play part of both an annotation workflow or an evaluation workflow. So stay tuned for some more information on that later in the year. But I think one thing you mentioned there, Ayan, also ties into, we got a question. This was a bit earlier in the webinar, so I think we might have already partially addressed that, but right, the question of like, how do you evaluate the evaluators, especially like when you have a lack of ground truth? And with that question, of course, what we mean is, how do you really ensure that your LLM judges are aligned with your expectations, right? And that a lot of Oscars showed how you can build that out into Super Annotate, but it's really a lot about that collaboration, like human machine collaboration, you can say, or human AI collaboration, right? Of having your human experts figure out, what metrics matter, be able to evaluate the data set, and then kind of iteratively create an LLM judge on that sort of same ground truth data set until you reach like agreement, and then keep monitoring that in production. There isn't really, at least not that I've heard of, a great shortcut completely around that. You do have to validate that your models work, especially like when it's a higher stake use case. Do you have any other thoughts around that, Ayan or
Yeah,
Oscar?
that is absolutely right. I think we need to human and LLMs work together in unison to figure out the scenario. Also, we have something there's something called automated reasoning checks, which is more like a deterministic way of evaluating a metric. And that we can run on a subset of the data and compare that with what LLM is generating, right? So that can also be one of the technique that we run a subset of the output which LLM has generated through some automated reasoning checks, which is more deterministic.
Yeah, I think it's always hard. It's kind of like, yeah, how do you evaluate the evaluators? But you can kind of, I guess, kill two birds with one stone when you're starting out and you're reviewing a set of data, you're evaluating it with people, which means that for the model that you ran, you're gonna get a human validated evaluation of those models. But you can also use that data set afterwards to benchmark the judges here, like run them new judges that develop across the same data, see how they perform. Just make sure that the human metrics and the judge metrics align. That's not always the case, so keep that in mind. But moreover, you could also use this data to potentially fine-tune the judges or just do some kind of prompt optimization over that data as well. I mean, writing prompts can be hard. So that's another way in which you can kind of kickstart this.
Yeah, I think those are great points. And one thing that we also like to recommend to customers, and that we see customers do as well, is like, even when you have your LLM judge deploy, you have it, tested and validated against your data, you deploy it, maybe you have a model in production, and you have your judge like continuously review data there. don't completely trust it just because I aligned it once, it will stay aligned forever. You might see new usage patterns. There might be new errors that come up that you haven't predicted. So oftentimes a workflow where you do keep humans in the loop to some extent continuously, maybe reviewing a small percentage, a 1%, 0.1%, depending on like the volume of data you have of all those examples that go through the judge, to keep your eyes on like this. Does it keep agreeing, detect cases where it disagrees, and then be able to go back and kind of refine and improve that judge based on that data and add that to your sort of ground truth evaluation data set later on. So it's really a continuous process here. We did get one great question too, like, so, okay, I have my evaluation results in place right now, but like, what are our recommendations for actually using those evaluation results to improve the application and model? And how can you enable decision makers to see the value of iterative model evaluations?
Yeah, I can take that. So I think that's where techniques like RLHF or reinforcement learning through human feedback comes into play, which is where we create a feedback loop from either the evaluated results online or offline, where the users come in annotate the data. We take all of this, like the output of the LLM as a judge and also the annotated results, feed that back into the model, right? And use it either to fine tune the model and probably in the next version of the model, if you ask the same question, it will have better results. So that's how, so the technique is RLHF, reinforcement learning through human feedback.
And I would say I think I mean, these GenAI systems that we have right now, you can have a lot of statistics on how they're performing on different metrics and so on. But we've also seen that some people, you want to have a human feeling on what's going on as well. Like, how is it changing on these model iterations that you're making? So as Leo mentioned, like having a very small data set and iterating with a close group of people as you're trying to release a new version can be quite good. And you're going to get some metrics, right? But they're not necessarily going to be statistically significant, but you're going to get a lot of qualitative insights from a group of people who know the model and know the application very well. And almost like, hey, the model is changing a bit how it's asking things. It's becoming more, say, sycophantic, or it's more agreeable or something else, which might not be something that you're measuring today even, but you can get a feel for stuff that you can then go and investigate and see how you can improve too. So yeah, a little bit of both.
Yeah, I agree with that. And I think also one real key to be able to effectively use your evaluation results for improving the models, it kind of ties back to like what we discussed earlier in the webinar, right? One of your key first steps should be figure out like what metrics truly matter to you. You can go through like the process of like manually sit and go through 100, 200 different examples, like the full traces, both input, tool uses, reasoning if it's an agent, right, or input, output, it's a model. Try to find out like where do I have errors right now? What are the things that are going wrong? And sort of build out your evaluation criteria based on like the metrics you target are those specific measurements of things you know go wrong. And then knowing both the prevalence of that lets you kind of help focus your efforts on where you have the biggest problems, targeted work to improve them, and then kind of continuously do the evaluation because that's the way you can see you're actually getting closer to those goals, and see how those errors hopefully gradually disappear, right? And you're also able to test like, did this change I did to my model or my system, did that actually measurably address that metric that I'm tracking for that specific type of error? And like, if you don't do any type of evaluation like that, it's very hard to like have that type of really measured data-driven model improvement. So I do think evaluation results are key to be able to improve your model setups. I mean, at least when you have more advanced AI systems, it's not like we're saying you should set up, an LLM as the judge and eval system for if you're using ChatGPT to help you write emails, right? But especially when you come into more complex domain-specific agentic workflows, it do become really important to be able to like measurably improve your system, just like you do unit testing for software programs as well. I think that pretty much answers those questions that we got in right now. And we're closing up on time, so I do want to wrap up. Before people leave, I would love to say that we have a couple of resources we put together. A white paper we wrote about evaluating things that kind of captures a lot of this and much, much more information that we have a link to in the chat, together with a workshop that we're running right now. So if you're working on a larger, agentic AI project, we have a workshop that you can book where we help you get started and kind of get an evaluation set up for your model, and then work together with you to see how we can help you get that evaluation program kicked off and into production as well. So do sign up for that if you're working on a larger project and need some help getting started. And as always, you can also navigate into SuperAnnotate and click the little book a demo link and write a bit about your use case. And we're very happy to jump on a call and chat more in detail about how we might be able to help you kind of get that AI from a pilot into production. So thank you all very much for being here, and thank you, Oscar and Ayan, for jumping on this webinar. And I hope we'll be able to do a couple of more with you in the future as well.